So amazing being here with all of you. And I was thinking that last time I was at Scale by the Bay was obviously pre-pandemic. And back then, as Alex has said, I was at Confluent, I was an architect. I talked, if I remember correctly, about how to make Kafka streams reliable on top of Kubernetes. So fast forward four, I think, eventful years. And good memories brought me back, and honestly, I forgot how beautiful the place is and how awesome the community is, and it's so good to be with you here. And I chose to talk about things that databases don't do, and I really appreciate all of you for being here because it sounds like such a silly topic when you think about it occasionally. There are so many things databases don't do, right? I mean, I woke up this morning. I manage a lot of databases these days. Not a single one made me coffee this morning. I had to go, thankfully, Alexei and his team had very good coffee over here. Otherwise, who knows what may have happened. Worse than being a bit silly, the talk may sound like it's a bit useless. Okay, you're going to sit here for an hour, half an hour, whatever, listen to me, talk about stuff databases don't do. What do you have at the end of this half an hour? You have a list of stuff databases doesn't do. What are you going to do with this list? Are you going to go out and write a new database? Well, if you are going to do it, please come talk to me afterwards because I need some people who are crazy enough to want to write a database. But if you are a normal developer who probably want to do literally anything except write his own database, then what do you do with the list of things databases don't do? Well, there's two very useful things you can do with this list. So the talk is not as useless as it sounds. The one thing you can do with this list is to know what are things that you are very likely to need to do in your project, and you have to do them yourself, because unlikely that your database is going to be much help on that. And I'm going to talk about things that we all had to do over and over and over again, so very little science fiction, and I'll point out the science fiction a bit. The other side of it is that for everything that I point out the databases don't do, there is one or two databases that actually do them. And if those specific things are actually extra important to you, it can be a method of actually picking a good database for the project you are about to embark on. So thank you for showing up for a talk that sounds a bit silly and a bit useless. I promise it will not be completely useless. And worst case scenario, it is going to be a good rant because I'm annoyed about every single one of those things separately and extra annoyed about all of them put together. Okay, so there are a few categories of things that databases don't do. I'm going to have one or two examples in each category. Things that databases don't do, but actually claim to do. Things that everyone needs and databases don't do. Things that software engineers specifically need and databases don't do. And then some things that may be a bit more futuristic, although honestly, they become less and less futuristic by the day, so who knows. So, to start this, one thing that a lot of databases claim to do, and they don't, is claiming to be able to do everything. Pick any database in the world, anything that comes to mind, and it's usually architected in a specific way for a specific purpose. So it's usually databases, when they're good, they have a good architecture. Good architectures are coherent and cohesive. They have a lot of small decisions all aligning together to support being good at something. It's everything from how you lay data on the disk, the type of indexes that are available to you, the way memory is laid out, the way the network is optimized. Every decision that has been made to be good at something. And it's not the same thing for all databases. If you have relational, you have the non-relational, you have OLTP versus data warehouses, they're all very, very different. And a lot of them say, no, I'm actually good at everything. I can do OLTP and data warehouse. I can do NoSQL and SQL. I can do relational and non-relational and documents and graphs. In my experience, it cannot, technically speaking, it cannot possibly be true. How is your files optimized? What are your indexes like? How do you allocate CPU to tasks? all those things actually matter. So I tend to be extremely skeptical for a database that claims to be good at everything, because either they're good at one thing and kind of fudging the rest, or they are not very good at any one of those things. So that's my take, and something that when we started my company and I sat with my co-founder and kind of thought through how to design our database, that was one of our insights, is that we cannot possibly be good at everything. Everyone wants, it's very tempting to say, I want this one database that will do absolutely everything for me. I will never need anything else. But we think that the same way that databases are built for a purpose, data platforms are engineered for a purpose. And the way data platforms are built, the purpose is usually a business goal or a specific type of business. And you pick and choose usually more than one database, a set of technologies, you put them together and make sure that this architecture now aligns with your business goal versus every one of the database which aligns with a more technical goal, if that makes sense. So don't believe databases that do everything. On the other hand, it's your job to build a data platform that does everything for your specific vertical. Okay, so let's go to stuff that databases don't do and we all need all the time. And the first one is soft deletes. And I'm pretty sure that everyone in the audience have had to deal with it about 1 million times. I've had to build it 1 billion times in my career. The idea is that a user goes to your application and clicks delete, and the last thing you want to do is actually delete the data. Why is that? Well, because we all know, I see a lot of birds even longer than mine in the audience, we all know that it's a matter of 10 seconds, 10 minutes, 10 hours, 10 days until they're like, oh, fuck, I actually needed this. Can I get it back? No, you really, really need it back. And database recovery is usually one hell of a pain in the ass. So the way we normally do it is mark it as deleted, we turn a flag, we put a date, and then we have a lot of application code saying if this flag says deleted, just pretend the row is not there. And then you have another process 30 days later. I don't want to go to jail. I don't want to pay GDPR fines 30 days later. Actually delete everything that was deleted 30 days ago and nobody suddenly like, oh my God, I needed it. So we did it 1 million times and we're still doing it. And I just did it recently, again. Why? Why do we have to do it over and over again? Isn't it obvious for the last 30 years people have had to do it? Can't databases actually have soft delete built into them if it's so obvious? Anyway, yeah. So that was the first one. The other one, and this is the one that I am focusing on when my company, and this is the first time I'm actually allowed to say it out loud, so this is pretty cool, is tenant awareness. If you think about how databases are used today, especially in software as a service, we usually use the same database for a lot of customers. If you are, say, Salesforce, you have one big, I don't know, Oracle, MySQL, whatever it is that Salesforce uses, and most Salesforce customers somehow fit into this one database. This is not something that databases today make easy, even though there are millions of businesses probably that all have to do the same pattern. So what we normally do is pick one step before that. If you think about what you need in a database that has a lot of different customers in it, it may sound like, what do I need? I just need to put them all in the database, but there is actually a lot of small things you need and maybe you don't know that you need. Or if you have a lot of experience, you don't know that you need. You need, first of all, most important rule of putting a lot of customers in the same database is don't let them see each other's data. We call it data isolation. This one can be a career killer / business killer. It's really, really bad. Customers absolutely hate it. So this is important. Most places, you also want to be careful about performance. You want to make sure that if one customer suddenly has a burst of activity, it doesn't actually affect everyone else. And then there is a lot of things about being able to upgrade your customers independently and to recover them independently. There were, I think, a year and something ago, Atlassian had a very visible outage. It actually lasted for weeks because they didn't upgrade. It was harmful for some of the tenants on their multi-tenant system. It was Atlassian Cloud. And it took a very long time to manually recover every single one of the customers because they didn't really have a lot of tools to do maintenance on specific customers and leave the others alone. So those are all things that you usually only discover that you need kind of late in the game and the hard way. Now, in order to build those multi-tenant systems, we usually end up with one of two models. So on one hand, we have the idea of we'll put all of them in one database, we'll have in every table the customer ID row, and we'll put a lot of code in our application to filter out the stuff we don't need. This is very good for being cost-effective, very manageable. Of course, puts a lot of burden on the developers to make sure that if you need to do something specific for a customer, writing the right scripts, making sure the data access is correct, making sure nobody uses more resources than they're supposed to. The other model is give each customer its own database, or sometimes it's its own schema, which is slightly better, but maybe somewhere in between. And in this case, you actually have pretty good isolation. You are able to maintain every customer independently. It's easier not to leak each other's data. On the other hand, you still need to do all the tooling and scripts to manage all those systems. So either way, it feels like databases don't do a lot for you, and the choice is not really easy. And we've seen people who chose either path and wish they have chosen the other, which just shows that it's not very easy to make the right decision. The way we're imagining the world, and by we in Nile, is that it's actually a false choice. It is possible to take one database, isolate tenants within it, and allow to perform a lot of the operations either on the database as a whole with all the tenants or on specific tenants. So back up the database versus back up a tenant. Restore a database, restore a tenant. Query a database versus connect to and query a specific tenant, all the way to geographical distribution. I want these tenants in the US, those tenants in Europe, obviously different performance, different regulations, and so on. So moving on, another thing that we are not building, but I wish someone would have built, is an easier way to get changes out of a database. And what do I mean by that? Basically, as you know, if you have a database, people are doing inserts, updates, deletes, all of that changes the data. And this information, that something changed in the database, is obviously extremely useful information. You can use it for auditing, for push notifications, for replication, like there's so many use cases, which means that pretty much everyone here in the audience is working with a system capable of getting changes out of the database and doing stuff with them. And because it's so useful and because everyone is doing it, there is a lot of technologies to do it. I've listed some of them, just a tiny subset. But those are all different technologies outside the database, right? So let's say I want to use the Debizium and Kafka and then Flink. Well, I need to run the Debizium and then Kafka and then Flink. They probably have different security models from the database, but they shouldn't have different security models from the database. If there is a person who is not allowed to see row A in table B in my database, I probably also don't want him to see the changes to that row. I don't want him to see the row in other systems. I may allow them to see the row in aggregate after I do a bunch of analysis. This may be OK. But we need to have a way to align all those different systems and run them and manage them in a more unified fashion. I can only wish that databases would have, instead of, OK, I need to run the Debizium, and I need to connect the Debizium, and then I need to run Kafka, and then I need to run Flink. Like, can I just tell the database, please put all the changes in S3? That's all I need, really? Can you do that? So it turns out that no, they really cannot. OK. Now, things that are more specific to software engineers and the way software engineers work with data. So if you happen to be data analysts or data scientists, this may be less relevant, but who knows, because engineering best practices do find their way into other disciplines eventually. So let's say that you're a software engineer and you want to change the database schema. This is not rare. Pretty much every time someone asks you for a feature, it's like, oh, I need this extra column, and it needs a foreign key over there, and maybe an extra table, this new enum type, and also I need an index. Okay, what do you do now? Well, the way things normally start is that, okay, you now have a system in one version, and you work on a local copy, and you make local changes. Usually where you end up with something called a migration file. And then you do all your work in a branch. So now you have a branch of your code. It has a migration file, and you have a local database that has all your changes. You tested them locally. Things look good. Fantastic. You push it to your source control. If you have a functioning CI/CD system, which hopefully you do, it will go there automatically. So you'll have a dev system that has the new schema, and maybe you'll have a staging system with the new schema. A bunch of tests will run automatically. Maybe some developers will use your test system and kind of give you some feedback. So when you decided that stuff is in a good shape, you finally close a circle, you merge your branch, your magical CI/CD system pushes this to production, and now production is on version 18. What you absolutely do not do, unlike everyone on my Twitter feed when I asked about this question, you do not SSH into a production database and run a bunch of alter table commands. This is absolutely guaranteed to end in disaster. There are several ways to run those migrations. You can have sidecars doing it, people do it in containers, people integrate it with the CI/CD systems, all good. Don't be the guy who SSHs, please. Anyway, that was a side rant, because I was absolutely horrified by people on Twitter. The data gets to production. Note that throughout all the system, your version control and your CI/CD was very aware of changes going on, and it triggered a bunch of checks and deployments and so on. The database, on the other hand, was blissfully unaware. For it, one day, a bunch of unrelated changes showed up. A column, maybe a new type, maybe a new index. They just appeared one day. It doesn't know that before that it was version A, and after that it's version B. It cannot warn you, hey, the changes that you're about to make are actually incompatible with something that is already running. It cannot let you flip back to the old version if you kind of miss it for a bunch of reasons. So a version control is something that would behoove databases to move to what has been a standard engineering practice for pretty much as long as I've been engineering, which is like 20 plus years. So I feel like it's about time. There are databases who do it, by the way. As I mentioned earlier, for everything I'm talking about, there are some databases that are a bit more advanced. There are databases out there that actually have version control. I think this is one place where we will see more and more of it, as it proves very useful. Another thing that engineers love and databases don't do very well is APIs. So if you want to query a database, usually we write SQL. SQL is lovely. It looks good. It's readable. I think everyone in the audience can tell me what I'm getting over there and why. Fantastic. Now, if I write the equivalent using one of, I don't even remember which exactly library I used there, but most query builders are the same, so roll with me here. If I do the same thing in, let's say, Spark, then it's arguably less readable. But being code, it is better structured. And this is the important difference. So let's say that I want to have a variation on this query somewhere else in my code. I want the same thing only with a filter. If I'm doing everything in SQL myself, either I have two copies of the same query, and now I have to maintain both of them. Engineers absolutely love having two copies of the same thing and maintaining both of them. That's what really drives us. Or I have to do string manipulation. Not that fun either. Actually, a recipe for disaster either way. If I wrote it in code, on the other hand, again, I don't know how readable it is, but it's composable. I can store the original query and then reuse it somewhere else, attach a workload to it, store both of them, pass them around. I can now manipulate queries in different places in my code without having copies and without the risks of string manipulation. This is a really, really good thing, and I think 90% of the reason people use ORMs is not because anyone loves ORMs. Anyone here loves ORMs? Oh, wow, okay, there are people who like ORMs. Sorry about all that. I know, I did a survey. 50% of the engineers love ORMs, 50% hate them. I think this crowd may have more people who either hate them or neutral. But regardless, I think a lot of reason why people who even hate ORMs still use them is because of the nice ability to compose queries. But ORMs have downsides. A lot of them don't produce the most optimal code and the fastest, so you have to keep stepping outside them for a bit. What if, hear me out here, what if databases actually had APIs and allowed you to use structured languages, like better structured? I know SQL has like the S that are supposed to say structured, but I mean actual structured language for querying them. Which brings me to the other point. Databases don't just have a slightly antiquated programming language attached to them. They also don't really do modern protocols. Let me walk you through my thinking here. You have a database. We already mentioned that it talks SQL. How does it talk SQL? Well, some databases are open source, but they still, each one of them has its own binary protocol, unlike any other database in the world. So you need database drivers that can talk to that specific database. That's number one. You have to authenticate to it. You usually use either the database built-in authentication or LDAP or Kerberos. So slightly antiquated authentication methods as well. Now, if you look at the other side of the world, you have your application. These days, 2023, a lot of times your application is running in a browser. It talks very like browsers do in the HTTP protocol. A nice modern protocol invented, I think, somewhere in the early 90s, so 30 years ago, but it has some organizations on it, and databases and browsers usually support those. Databases, of course, know absolutely nothing about it. If you authenticate in a browser, very often you use basic auth, another antiquated protocol going back 30 years, or you use more modern things that are only 13, 14 years old, like OIDC and SAML. How do these two things talk to each other? I have data in the database, I want to show it in my browser, they don't talk the same protocols, what do we do? Well, we know what do we do. We all do it all the time, right? We put a backend in between. That backend takes query in HTTP, authentication in OIDC or SAML or basic auth, translates it to SQL, sends it over a different connection using a different protocol with different authentication to the database, gets a response in database protocol, converts it to an object, converts the object to JSON, sends that back over HTTP to the browser. Do we add value when we write this backend? Sometimes. Sometimes it has a lot of business logic, super valuable backend, I love it. But how many times did you write a backend? It's like literally pure translation. And we talk like, yeah, it's good engineering, separation of concerns, etc. And sometimes it is, but it's also losing value in a serious way, because in all this translation, we can introduce bugs easily. We can lose security because we have to also translate credentials coming in for a user from the browser to credentials that go to the database. This is not always a good thing. And we do it over and over and over again. So in the same organization, right, we usually have a lot of backends, sometimes even a lot of backends talking to the same database. A lot of opportunities to mess up access control, security, permissions, etc. Not very good in my opinion. What if databases would actually talk in HTTP? that would be nice. What if they would support modern authentication protocols? They're not that modern. 2010 is not even that new. Yeah. Okay, let's talk about things that are not 15 to 30 years old for a second and maybe more modernistic. It's funny, I wrote this talk originally almost a year ago, and it's scary how, like, I looked at it and like the things I'm mentioning is modern. I don't know if they're still modern. So a lot of change in a year. So the first one is that a year ago, definitely 5 years ago, most databases were in one place. You needed very special requirements. You needed to be a very big company, pretty advanced, to have a database in the US and in Europe. Like this was like, oh my God, science fiction, or you have to be like Netflix or something. But I think today it's no longer true. There are 3 forces driving us toward more global databases. Actually, 2 forces and maybe 3 use cases. The first one is simply compliance requirements. Data, there is a lot of data residency regulations. If you're a company with customers in Europe, there are locations where you're not allowed to take the data out of the country. Sorry about this. If you want to have those customers, either you make them sign the release consents. They are pretty reluctant to do that, let me tell you. Or you actually need a database in their side of the world. So this was one very big driver, just regulation. The other thing is latency. In general, people like when their website is fast, but also it was never enough of a driver to put the database on the other side of the world. A lot of times you did some caching and it was good enough. But until very recently, it was all about serving this customer in Japan that has really bad latency. And the people in Japan are used to having bad latency, I guess, and they kind of deal with it. What really changed recently is the rise of serverless. More and more backends and workloads are running on things like AWS Lambda, Cloudflare, and those may be closer to the edge. Someone called me literally yesterday with, hey, my workloads are in Asia Pacific, my database is in US West too. It's a bit of a long round trip. And the thing about serverless is that it's now not about the grumpy customer in Japan, it's actually costing you real money. Remember that in serverless, you pay for CPU seconds or minutes. Every second your function is running, it doesn't care if it's waiting for the database, TCP handshake to keep doing back and forth. You are paying for every second of it. It's amazing how many people start caring about latency when they notice they're paying for latency. So this has obviously kind of become a big deal. So we see more and more databases and caches going global. Database replication is actually in a fairly good place. It's not that hard to get your data from one database to another, putting them all over the place. Of course, the database itself doesn't know it's in Europe. So it doesn't say, hey, I'm a European customer. I will make sure the data never, ever makes it all the way back to the US. It doesn't say, oh, I'll make sure that if someone click delete, the data will be gone, even from our backups within 30 days, because I don't want you to go to jail. So there is more databases can do in this new landscape. And of course, with keeping caches out up to date, all up to you. They're doing absolutely nothing. And there's so many nice things they could do. They have the change logs. They could push it proactively to all those caches. They could give you warnings. They could do some routing. So if you query the cache and it's not up to date, but you say it absolutely has to be up to date, they route it correctly. There is so many things you could do better there. You could do better, you should do better, but you have to do it versus the database doing it for you. And last bit for futuristic. This is the one that I'm like, is it actually futuristic? Databases traditionally has not been very intelligent about their workloads. You tune them, and however you tune them, that's how they're going to keep working, and the intelligence is ours, not theirs. But recently we've been seeing databases or even systems running on top of databases where they say, no, actually, I'll be studying your workloads. I think I can build better indexes. And it's not just about figuring out where to put an index. It's actually saying, hey, you have this very large index, but only 5% of the data in this index is actually accessed. So I'm going to index a subset of the data. Or this index structure is more, the traditional B tree is not the right structure for you. We can restructure the tree so you'll have shorter passes to the data people use most in your database. And we'll do it behind the scenes and on the fly. And we've seen systems do it these days. Very new, very cutting edge. They, on one hand, scare the crap out of me. And the other hand, I mean, how do you even troubleshoot stuff that changed behind your back? But on the other hand, it's very promising. I mean, in general, making a database perform well at scale is a hard job. There are some people in the world who can do it. Some people hire them, and then most companies really struggle and move to a bunch of questionable NoSQL solutions because they haven't been able to solve it. But what if you can democratize it? What if you can capture the intelligence for tuning a database and make it part of every database in the world? Some workloads have to be in NoSQL, no doubt about it. Some of them, they may be in NoSQL by mistake because someone told someone else that NoSQL is faster and they failed to tune the database. I've seen a lot of it. Tuning a database is actually pretty hard. So I'm pretty excited to see how those intelligent databases evolve. And again, like this is the thing I'm most skeptical of. I've seen so many attempts to do it that failed. You have no idea. But I'm seeing the people who are working on it. And it's like the top professors from the top universities who've been researching databases for 20, 30 years. And I'm really hopeful that this time it's going to work. And mostly because in the last year I've seen a lot of things that I would never believe going to happen actually happen. Thank you. OK, summary. Don't believe anyone who tells you their databases do everything. Keep in mind the stuff that you have to do because databases don't do it for you. And keep watch for databases that are faster and that do more for you when possible. One last thing. Why do databases get away with doing so little? It's all our fault. How does technology get better? Technology gets better because the people who use the technology ask for better things. This is how everything gets better, because of consumer demand. For databases, all of us, technical people, are the consumers. But technical people tend to apply their own beliefs that things are impossible, and it prevents them from asking the vendors for more. So if I believe that having a database auto-tune itself is impossible, I'm not going to go to my vendor and say, why aren't you auto-tuning your database? Which means that the vendor has no incentive to make it better. I really ask everyone here, please raise your bar. Ask for more. Be more demanding. Be more demanding of your vendors, but also question your own beliefs when you say something is impossible. Because over and over, things that I thought are impossible, like Dallas 3 creating actually usable pictures for my blog, they are now possible. So who knows? And it wouldn't exist if people keep imagining that things are not possible, they will remain impossible. And if we stand up and say, it is so stupid that it's 2023 and I still need to implement my own soft delete, what the hell? Things are actually going to stay this way. So please reconsider your standards, reconsider what is possible, and raise your bar for what a good database really should give you. Thank you very much.